Yeah,
So, okay, Prathamesh, the floor is yours. Thank you very much. See you later.
thank you. Hey all, hello. My name is Prathamesh Sunpatki. I work at Last9 building tools for SREs. We provide visibility into Rube Goldberg microservices. So if you don't know what Rube Goldberg is, Google it. But after my talk, not right now. Please hear me for next 30 to 40 minutes. But Rube Goldberg is definitely fascinating. Do check it out. I'm excited for this talk on how we can use OpenTelemetry to peek inside our Rails apps and see how they are performing. Let's get started. But first, I have a question. Why all of this even matters, right? We already have so many great things happening in the Rails world. We have already like Hotwire and all those features that are coming in Rails 7. Do we even have to care about instrumentation? Is it like the problem that is already solved in 2022? And why do we even have to think and talk about this instrumentation, open telemetry, and all of that, right? Well, development is one thing that Rails is great at, and it makes our life extremely productive as developers. But how do we know even that our application is working once it goes to production? How do we know that even it is working as expected and everyone cannot come to our machine to see if it works or not? Like we can say that, oh, it works on my machine, but that excuse won't work once it hits production. We also may have some external commitments with our customers, or the customers may have commitments with their customers. To even prove to them that the things are working as expected, we need a way to measure how our application behaves. Last but not the least, we all need good night's sleep. We can't just sit there staring at our screen all the time, right? So we definitely need a downtime where we can relax, rest, and then come back tomorrow for the new challenges that are already there. So we need a way to find out how our application is performing really once it hits the production. Hope is not our strategy, right? It cannot be our strategy that we just push everything to the production and just hope that things are working fine. We have to do something. We have to take some action. So the reliability mandate starts with instrumentation. We have to measure first. Only then we can improve what we are measuring. If we want to think about making our apps and making our software systems reliable, we have to start with instrumentation. That's the first step. When I talk about instrumentation, I also would like to touch upon how the modern software systems sort of behave, right? They're not standalone apps that we deploy on VM, or they're not standalone apps that we deploy on, let's say, EC2 instance and so on. What they are is basically they are applications which are connected to other components, such as, let's say, load balancer, CDN, or external database service that we are using. What I would like to say is that they are like burgers. So this analogy is where the application that we write, the Rails code that we write, is like a patty, which is where all the business logic resides, which is where all our beautified and tasty patty is. The buns, which are the service providers, they are standard. You can choose between one or two buns, right? You can choose between AWS. You can choose between, let's say, Google Cloud or Azure, or don't choose Azure today; it's down by the way. So, but you can also choose between service providers like Heroku, Render, Hatchbox, and so on in the Rails world. But those are the buns; those are the standard choices out of which you pick up something. Additionally, you also have menu sauce and ketchups like third-party services or databases and stuff that your application talks to. So this is how basically I imagine modern software systems. And all of this leads to basically full stack observability, because when we think about the software system as a whole instead of just the application, what happens is that we can't just rely on getting information from just the application. We will like to have information from all the other components as well. And often this leads to full stack observability. So, just a quote from me: modern software systems are complex because they are like living organisms. They grow and shrink in all possible ways and directions. And more importantly, there are other peers like that with whom they communicate. So, it's not just one complex system that you're dealing with. Probably you are connected to some payment gateway, or probably you are connected to some other system or your own microservice, which is also designed and working in the same way. So that is how the modern software systems are. Now, having covered the necessity of instrumentation for making sure that our apps are reliable, I'll cover rest of the agenda that we will cover today. We will go over some basic terminology that will be useful for us for rest of the talk. We will cover what is even OpenTelemetry is and how it started. We'll go over the architecture of OpenTelemetry or OTel. It's a short form that people use for OpenTelemetry. Then we will connect all the dots together and we will see how we can even use it with Ruby on Rails. With a application, I'll try to do a live demo and see if it works. Obviously, I hope that the live demo works. So let's see how it goes. At the end, we'll talk about the way forward and how we can start using these in our applications, along with some limitations and other constraints that are there. So that's the agenda for today. Let's get started. We'll cover the basics here in this section. So even if you know some of these terms, it's better to brush them up quickly before we go deep into some of the deeper topics that we want to go. First of all, I'll talk about observability. Observability is nothing but our ability to understand the state of the system. And how do we understand that is basically the internal state of the system based on certain outputs that the system produces. So the way it has to work is basically that we have to provide certain data from the system so that we can understand how the system is behaving at any point of time. Making a system observable basically boils down to this part of producing relevant data. And that also, in a way, that can be measured, observed, and acted upon. Because if you are just producing the data, but not even producing it in a way that it cannot even be measured or consumed, then there is no sense of even like producing that data in the first place. So the idea is that you produce the relevant data in a way that can be observed and acted upon. That's the observability. Then there is also telemetry. So to make a system observable, we need data. Telemetry is a way to get that data in an automated fashion, obviously, because we don't want to do things manually all the time. And also getting this data from all components of our burger, not just from the application, but from other components as well, and then sending it somewhere where we can make sense of it. So basically, telemetry is the whole flow of information from the source to the destination, and then at the destination, we basically will use it, visualize it, measure it, and so on. Then there are logs. If you think our Rails apps, what it produces as an output, logs is the first thing that comes to mind, right? So every Rails application has those three files, development.log, test.log, and production.log, which we use for checking how our application is performing. It logs basically all the request logs as well as some console print statements or debug statements that we have. Logs basically provide a way to understand what's wrong and why, as they point to a specific line, right? So logs are the best friends of developers because when I see a log and if something is wrong, I can quickly spot it in log, and then I can basically fix that issue, send a pull request, merge request, and that issue gets fixed. Logs can be structured, which is the example of our standard trains logs. So here we can see an example of a post controller, which is emitting a log in a certain way. When I say structured, what I mean is that they are not haphazard debug statements like, hey, I'm here versus, hey, I'm like, is it even working? Something like that. All of us have seen such logging statements in our code. But structured logs are slightly different. They have a pattern, they have a start to it, they have an end to it, and you can basically consume them by writing a parser and then make some aggregation out of it. So you can basically say that if you can write a parser for this kind of log that we see here, we can find out how many such requests that came for the slash post endpoint, or what was the average time that took for all of such requests. So structured log helps us in extracting such kind of information. There are unstructured logs also, which are like debug statements, console statements, and so on. They are basically very useful for debugging, but not necessarily helpful in terms of extracting some information out of it. So Any guesses so far? What can be the problem with logs? Logs are great, right? Based on what we saw so far, they help us in debugging. They help us in finding patterns. So what else can go wrong? What happens is that when the logs increase a lot, it becomes very hard to find information out of them. The other challenge is when we consider our burger analogy again, you will have different formats of logging for different types of components, like your other components that your application is connected to. They may use some other format completely. So while for logs, the adoption is easy, the consistency is hard because there is no structure that you can basically say that all logs will be of the same format. Either you have to force it, but also it becomes hard to force it in terms of microservices or when you have different languages, because each language will have its own format, and every framework, even within the same language, will try to log differently. So what people generally do in these cases is they basically use something like JSON logger and so on to make unstructured log structured and then consume it somewhere. But that is how basically the logs are. Then there are metrics. Metrics give us answers for what may be wrong. Logs are basically giving answers to why it is wrong because they pinpoint to a particular line. But metrics are overall idea of what even may be wrong at any point of time, or do I even have to go deeper, right? They give a starting point to notice the issue, after which we go deep into the debugging mode using other tools. Metrics are mostly aggregates. So you want to see an overview of, let's say, how many requests are my application is getting over time, what is my throughput, what is my P99 latency, and so on. So you aggregate the data and then extract metrics out of that. Metrics allow consistency and adoption, as all of the metrics ultimately boil down to 2 to 3 types of metrics like counters, gauges, and histograms. So even when different languages are there or different frameworks are there, they will ultimately boil down to these standard data types. So they do allow much better consistency than logs. So cross-service and cross-language adoption or cross-framework adoption is possible in case of metrics. For visualizing metrics, we use external tools such as Grafana. So you cannot visualize them directly in the application because they will have a standard format that may not be human comprehensible, but even plot like a better and beautiful charts out of them using tools such as Grafana, and then you can run aggregate queries over top of that. While metrics are good to start with in diagnosing a problem, they do not necessarily help in finding the root cause. For root cause, we have to look at other observability data that may be emitting from your application. So, while metrics are good, like not necessarily very good to understand the complete picture of why something is wrong. Then there are traces. Traces basically, as the name says, they trace the entire journey of a specific workflow. So, for example, in my Rails app, I have a sign-up flow or onboarding flow where the customer is coming on my login page, like putting email ID, try to sign up. Then I have 5 to 10 questions based on the customer profile, and then based on those answers, I show them some different data, and all of that I consider from a business perspective as a workflow. Then I will be able to trace the user journey across that workflow using these traces. They provide the necessary context for what exactly happened, and this context word is extremely important because we'll come to that slightly later as well when we talk about OpenTelemetry in detail. One challenge with traces, though, is that they have a lot of information because you will have to attach a lot of metadata attributes along with the traces. And every hop in your workflow basically retains the previous information and then adds some new metadata to the trace. So they can go like in terms of information, they can go out of hand. Like they are also similar to structured logs, but let's say in a debug mode, because in debug mode what happens is that you print everything that you can print, right? And traces can be analogous to that when they're run in production. So you have to take care of that part where you control the data that you are putting into traces. Then there are spans. Spans are basically building blocks of a trace. So trace is made up of multiple spans. And whenever we want to trace a workflow, in each hop, we will put one span. So it can be analogous to an event that is happening in a particular workflow. Let's say user is coming on to the sign up page, then user is hitting submit, then user is in the back end, there is some cross check that we are doing in our business logic that has the user already registered and so on. So all of these are can be considered as spans, and we can decide which ones to basically monitor and observe. A tree of spans make a trace, so that's how the trace is constructed. And as you may already guess, each span will have a corresponding trace ID, so that that context that we discussed earlier gets shared between all the parts of the trace. Basically, it is present in all the spans. So there are also these observability backends, which is where the picture gets complete. We emit the telemetry data in terms of logs, metrics, and traces, spans, and so on, and then it goes to the observability backend where we visualize this information. There are a lot of open source and paid services which offer these observability backends. Like Datadog, New Relic, Jaeger is an example of an open source solution that we can use. There is also last nine. So each backend has a different way of of ingesting the data, and each backend may also define their own way of formatting the data. So the problem that happens is that you never know that the format that I'm using for the current backend may even be useful if I try to switch to something else. Because each one can define their own format, their own standard. There is no common standard, right? And that's where OpenTelemetry comes into the picture. Observability backends basically come with these challenges of standardization. Switching between backends become difficult. Each will have its own way of formatting and so on. Also, one will have its own agent. So if you want to, let's say, switch from New Relic to Datadog in your Rails application, you'll have to change the code because you'll have to get rid of the New Relic line in your gem file. You'll have to get rid of the New Relic YAML file, replace it with Datadog gem or Datadog configuration file and so on. So it involves a lot of effort because of the lack of standardization. Also, there is lack of nomenclature. Like these standards don't have common names for things like, let's say, HTTP requests. Because even if you change the application, the standard nomenclature of, let's say, an HTTP verb remains the same. If you have a standard specification on these kind of attributes, then it becomes very easy to cross track them across multiple services and so on. And these facilities are not available in case of these multiple backends. There is no clear standard, and that is the root problem that basically OpenTelemetry tried to solve. But before OpenTelemetry, there were two open standards, and they were Open Census and Open Tracing. So Open Census basically provided a way to basically use and instrument the code using a set of language specific libraries. Each language will have its own gem or a library, and then capture the telemetry data and send it to the supported backend. Whereas Open Tracing provided a vendor neutral API. Vendor neutral in the sense that it is not associated with a specific backend tool for sending the telemetry data over to one backend, but it relied on developers to implement their own language to meet the specification. Basically, it provided the specification, but each developer would have to implement in their own code to basically satisfy that requirement. So these were the tools that were already available. But considering overall challenges into adoption as well as the cross-cutting concerns, it was decided that in 2019, basically both of them were merged into a single standard. And the interest of doing that was basically having a single canonical API specification or a standard for the telemetry part. So Open Census and Open Tracing were merged to form Open Telemetry, OTEL for a short acronym. And it is also part of CNCF as an incubating project. So it takes best of both the worlds of Open Census and Open Tracing and provides a standard that all of us can use. The goal of OpenTelemetry is to basically provide standardized vendor agnostic APIs, SDKs, and tools that we can use for ingesting, transforming, and even sending data to observability backends. And it doesn't matter whether the observability backend is, let's say, open source or commercial, because the APIs are completely neutral. You can use it to send data between different solutions and backends as well. So if you want to change from one tool to another and so on, it becomes possible by following this standard. So it is also important to understand what OpenTelemetry is not, right? It is not an observability platform. It is not an observability backend. It just supports exporting data to a variety of open source and commercial backends. So it provides a pluggable architecture based on pipelines that you can use to transform the data before sending to backend. You can even downsample it. You can redact certain information, such as, let's say, PII information or database secrets and so on. It provides that pipeline architecture that we'll see shortly, but it is not an observability platform. Let's go over the OpenTelemetry architecture, which is based on different modules and how it allows creating pipelines for transmitting the telemetry data from source to destination. Okay, but I think now enough is enough. Enough talk, enough slides. I think we should just do the demo first and then come back to the architecture, because the demo will give us the real picture about how things are working. So what we will do is we will have a short demo and I'll do some live coding. This is not recorded. We are doing it live. I have an open source Rails app called as Code Triage that I have set up locally, and I will use that to showcase the demo. Currently, it is not using the instrumentation. It doesn't have OpenTelemetry at all. So we'll do some. I'll show you how the OpenTelemetry part can be added to it. I am not doing all the live coding. So what I have done is that I have created some Git branches already, and I'll try to run those Git branches during the live demo. So I didn't want to take the full risk. So I had done some preparation on my demo. So let's see how it goes. Before that, let me have a glass of water and then we'll see the demo. All right. So let's go and try to see run this application. So the way it works is that I added few required libraries, gems, and so on in the code for OpenTelemetry to start instrumenting our Rails app. This is a Rails app, as you can see the specific gem file logs and other Rails structure. I'll post a link to this application later. It is available on GitHub as a open source application as well. So let's start. Let me run this and we will try to load this application, navigate to few screens and see if we get the data using OpenTelemetry. So here I have it already set up. I'll just refresh this tab. Okay, so things are loading. That's great. While it is loading, I'll also try to go to some screens so that we basically collect the instrumentation data for them. So I tried subscribing to one of the repo. I'll go to home screen again. And let's say I want to triage this repo as well. By the way, this is a great product to get started with open source. So you can go to codetriage.com and subscribe to some open source repositories where it will send you the issues over email, issues or pull requests, and you can basically help and contribute to open source. All right, so we went through a couple of screens. This must have generated the data. Let's go here and refresh it. Okay, I see code triage here. I don't know how it came here. That we'll see slightly later, but I definitely see code triage here. So something is happening. And I promise you that I'm running this locally. I'm not running it on a cloud or like I'm not mangling the data magically. Let's click on find traces and then I can see some data. Also, it proves that according to the IST time zone in which I exist, this is 6:28, few seconds ago. So this matches and I can see some data here. If I click on it, then I'll also see the default trace. But what I want to do is I want to go to a particular trace. So let's say I will go to this repos list request and I'll find the traces. So here I see the request for get repos list. and there I see the trace. Now, as we discussed, this is the trace. The trace has a lot of spans, and I can see those spans nested under each other here. This is the trace timeline. I can also see the trace graph, which is like a graphical representation of how the request processed. Additionally, I can also see the spans, individual spans, what happened in an order when the complete workflow got completed. I can also see things like flame graph and other stuff. So this is a fancy way of basically observing how much time it span took and so on. So if I click on this, it's a select request, I can see how much time it particular thing took. So I can see all of that. Then there is also a JSON format that we can export and like put it in some other system of our choice. So it also allows that. So yeah, we can see all of this data here. Also, it allows to compare two different traces. If you go to system architecture, we don't have anything here. The reason for that is basically we are running a single application as of now. We are not running two or three Rails apps. But if we do that and all of them are connected using the OpenTelemetry, then that will also, the graph will show up here as well. Then I will also try to go to some HTTP post and see if I can find something. So here I find one post request, and that is basically because I'm running the application in local. It is also showing this rack mini profile, which is included in my app. So I'm able to see that request here on the HTTP target is mini profile resources results. So when I was talking about the nomenclature part here, you can see that these names HTTP host, HTTP method, HTTP scheme, and status code being used here, they will be standard across multiple applications in multiple languages if you're using OpenTelemetry libraries. Because that is the way OpenTelemetry sort of standardizes these basic things so that you can correlate to them in different, even in different architectures and microservices. We also see few things like what was the process, the PID, and so on. So it helps in terms of debugging all of this information. So that's great. All right, so the demo has mostly worked. Let's go back to our presentation, and we'll come back to some code slightly later in the talk. We have one more demo to do. Let's see how it goes. But now we are back. So while we saw the demo, let's see how we can visualize it in terms of like a block architecture. So we had our Rails app, which basically use the OpenTelemetry SDKs, and I haven't shown you that yet. We'll go to that point a bit later. But let's hope that let's assume that it used some SDKs, some gems, and then it sent data to Jaeger. I saw it there as we saw in the demo. But I lied to you. There was one more component in between, which was actually doing bulk of the operations, and that component is basically OpenTelemetry collector. So our Rails app, it used the OpenTelemetry Ruby SDK gems. It sent data to collector using post requests. Then that collector had three steps in its pipeline. It received the data, processed the data, and then it exported it to Jaeger. So I had configured somewhere all of these things, right? And now let's see. Now let's see the code, what all I had to do for making this work. And as you may have noticed, there is not much code that I had to do. So the first thing that I had to do was in my gem file, I added these three gems, OpenTelemetry SDK, OpenTelemetry Exporter, and then the instrumentation all gem. So this instrumentation all gem basically has all the components such as let's say active record, active support, action view, sidekick, Redis, and so on. All the building blocks of a Rails application. And then I created a file for the configuration. So this is the initializer that got created. And in this initializer, what I did was I gave the service name as code here. This is the same service name that we saw in that drop down in the Jaeger UI. This is where it is configured. And then I started basically all the instrumentation using use all function, use all method. So there are also ways to customize this, load the specific parts of OpenTelemetry that you want, or don't load some part that you don't want to load based on environment configuration and so on. So all of that is supported. So this was like around 10 to 12 lines of code that I had to do. Now, apart from this, the question remains that how did all of this go into Jaeger? So where is the collector? So for collector, what I did was I started the Docker compose for the collector. So I like OpenTelemetry has an example of Docker compose for the hotel collector, and we have to run this. There is no choice. If you want to transmit the data to some destination, we have to run this. Basically, what it does is it uses this hotel collector config, and then you can configure some other services to where the data should go. So let's see what is inside that hotel configuration. So I'll go to the hotel collector and I'll go to the configuration. So as we saw in our image in slides, we had three things. We had a receiver, we had a processor, and we had an exporter before the data went to the destination, which was Jaeger in our case. So here also in this config file for hotel collector, we see three sections. We see the receivers, we see the exporters, and in those exporters, we see two specific destinations, which is Zipkin and Jaeger. And then we also give a port where they can receive the data. Then we have processors, and then we have service. Inside service, we have the pipeline. And as we saw earlier, like there are three basically building blocks of OpenTelemetry data, which is traces, metrics, and logs. Here we have configured traces and metrics in the pipeline. So traces, for traces, the receiver receives the data in something called as OTLP. We'll come to it slightly later. Then it processes all of those payloads in a batch, and then it exports it to log, Zipkin, and Jaeger. Similarly, for metrics, again, the same format is followed. It receives in OTLP format, processes it in a batch format, and then exports it to log right now because I haven't configured to export to Zipkin and Jaeger. So this is how basically the OpenTelemetry collector is configured. And then I just started it using the Docker Compose, and that's how the collector got the data which my application was emitting. So coming back to the architecture, what we have is we have the Rails app, which uses the OpenTelemetry to be SDKs and gems. It pushes the data to collector, hotel collector. Hotel collector has a pipeline where there is a receiver, processor, and exporter, and all of them are configured in certain way that they basically get the data and push it forward to the destination, which is later. Here you can configure any other destination as well, any third-party vendor or any open source solution as well. So that is how the like a overview of architecture of how OpenTelemetry works. So I have a pretty diagram to explain that as well. So I copied this example from this blog. So basically what happens is that here you will have code, APIs using the SDKs and other packages, sending the telemetry data to receivers. Then they will process it, export it, and then from here you will go to the third-party vendors and solutions. That is how the flow will work. All of this is viewed by the Open Telemetry Protocol or OTLP that we saw in that configuration file. OTLP describes the encoding, transport, and delivery mechanism of the telemetry data between the source and the destination, and even in between hops as well. Like it also defines how the data should go from the receiver to like processor to the destination. We usually we use this protocol in our code to send data from our app to the collector, as we saw in the configuration file, and we did it over HTTP because we were already using a Rails app. It the gems that we are using, they support HTTP based transmission of data, so it uses post requests internally. But OTLP also supports gRPC protocol. In our example, we use the HTTP protocol. Now, what we saw by that example was automatic instrumentation because we didn't have to change any application code. We just added three gems and one configuration initializer file, and we restarted our app. Nothing else was required, right? This is automatic instrumentation that OpenTelemetry supports out of the box. So what it allows us is that it basically gets us started. We don't have to do much or change the application code. We can just change the configuration and get started. But this doesn't have the application specific context. So if you want some application specific metadata, such as let's say user ID or a tenant ID in case of a multi-tenant application, we'll have to put that separately. So that's where the manual instrumentation comes into the picture. So manual instrumentation gives us deeper insights. We can attach custom metadata. We can have more control on the metadata that we are ingesting, and but it needs application code change. So we have to change the code somewhere so that we can change this. So I have an example of the manual instrumentation as well. That is the second part of the demo. So let's go to my branch. Not here. I'll stop this and then I will check out. Uh, okay, cool. So I'm now on my manual instru branch and let's go over the code. So what I want to do is when I go in my code triage application, when I subscribe to an issue, I want to attach the user ID to that particular trace because I want to know which user subscribe to what part of the which user subscribe to which repo. So the way I do is the configuration remains same. I just need to change one thing, which is I need to define a tracer. Now this my app tracer here allows me to create an instance of the tracer that I can use in the rest of the application wherever I want to add some custom instrumentation. And I give it a name that I will use to visualize in my Jaeger or any other dashboard, right? So this defines the my app tracer. Now I'll go to the repo subscriptions controller. And here what I have done is that I have grabbed the current span that is currently being in use. And then I have added an attribute to it, which is current user ID. Additionally, I have also added an event creating subscription. So this basically helps me trace the information flow because here I have a decision point. If the repo subscription gets saved, then I capture another event. Otherwise, I capture something like creating the subscription failed. So because I have a decision tree, I have added a event and captured that. Additionally, what I can also do is the my app tracer that we saw. We can also create a new span altogether, and let's try to give it a name like live demo, and let's see if it works. So we should see this in our Jaeger dashboard if all of this works, right? So these were the changes that were needed. We had stopped the app, so I'll start again. And after this, we have to basically go and create the repo subscription again. So we'll try that. So let me go to the home page. All right, the app is loading. I will go to asymmetrical and I'll click on triage issues. For just that we don't miss anything, I'll also subscribe to some other repo. Cool. Okay. Now I will refresh this. And here, let's see if we find our live demo. Oh, wow. So it's here. And if I click on find traces, I see the repo subscription trace here, right? And here, the live demo is basically part of somewhere in the middle, right? It was not the start of the request. The start of the request was somewhere here, but then we added a span to the existing flow, and that created a new entry here. So this is how we can do the manual instrumentation. Coming back to our slides, what is the way forward? What if I want to use this, and what are the limitations, constraints of OpenTelemetry right now? So the Ruby SDK currently supports only traces. You may have noticed that my demo doesn't have metrics and logs. There is a reason for that. The metrics and logs in the Ruby SDK are work in progress. The specification in OpenTelemetry already exists, and some other languages like Go already have support for metrics and logs. But the Ruby SDK unfortunately has support only for traces. There are some links that I have shared where more information can be found on these things. Who are already using OpenTelemetry, right? So GitHub is already using Shopify, Heroku, Puppet, Dropbox. They are already using OpenTelemetry. I hope that you got a good overview of Hotel in this talk. and you will also try to attempt that to standardize the way you observe and make your apps reliable using OpenTelemetry. So to recap, what we discussed the need of the standardization of the instrumentation process. We saw the essence of OpenTelemetry, what it is not. We saw the architecture. We also saw a Rails app, how and where to change the code to start using OpenTelemetry. We saw the difference between automatic and manual instrumentation and saw a short demo as well. And we discussed where to go next if I want to start using OpenTelemetry in my Rails apps. Thanks. That's all I have. My name is Prathamesh. You can find me here. That is my blog and Twitter link. We also have a community Discord where we discuss a lot of things about SRE, observability, reliability, and so on. So I would highly encourage joining that. And that's all I have. Thank you.
Thank you very much, Prathamesh. It was a very awesome presentation, a lot of information, very, very relevant. Prathamesh, let me ask you
Thank you.
something.
Yeah.
Speaking about the development life cycle, ideally we should have a test phase that would cover everything, right? That we don't have
Right.
any kind of failure in production. But considering your experience, what's the context that this open telemetry is being used? Is before the release or during production?
Great question. So this ties down to how you want to observe your systems, right? Generally, what happens is that in production, sometimes you may not want to introduce any latency, even for your observability system. For example, let's say if I'm sending data to Datadog or Neural Lake, or even using OpenTelemetry to some hotel collector, it may add some lag, some delay, and you may not be okay with that from a business standpoint. Let's say you are a streaming application. Any microseconds of latency that you add affects your user experience. So in certain cases, those kind of cases, people prefer outside in observability, where you don't add anything in your application, but you basically emit certain metrics and logs, which your application does sort of from the outside view, and then you basically use that for getting the picture of how your system is behaving. So at scale, what I have seen is that people using APMs and other tools in load test environment or staging environment, but in production relying on the outside in aspect, even not using traces in complete sense in production, only using it on demand and so on, wherever it is needed, not using in the critical parts. So it's a bit contextual depending on your business, but at scale, people have used outside in observability because it sort of avoids these challenges of having another thing to manage in production apart from the application.
Thank you very much, Prathamesh. Thank you very much. What was an awesome presentation. You have for sure a deep knowledge of what we're talking about. And let's see if we have any question for our attendees. It seems we don't. Well, it seems that they are all satisfied.
Yeah.
Okay, Pratamesha, would you like to say something before we call our next speaker?
I would just like to say thank you for organizing this conference. It's a great event, and running it online means that all of us can participate in it from different parts of the world. So it gives like equal opportunity to everyone to attend and learn from each other. So thanks a lot for organizing this event. Thank you.
Well, Prathamesh, I thank you very, very much. Your presentation was awesome. I hope we can keep in touch. And
Yeah,
thanks a lot, man.
thank you.
I see you.